This video will cover moderate part 1 questions regarding the topic of geometric sequences and series. This is the first question. It is the May 2014 SL Paper 1 question. Number A. General term UN equals Sn minus Sn minus 1. So U2 equals S2 minus S1. S2 is 5 plus 3k minus S1 1 plus k equals 4 plus 2k. U3 equals S3 minus S2 equals 12 plus 7k minus 5 plus 3k equals 7 plus 4k. U4 equals S4 minus S3 equals 22 plus 15k minus 12 plus 7k equals 10 plus 8k. Then number B, I will write down the first 4 terms. U1 equals 1 plus k, then second term, then third term, fourth term. And think about the number part. 1, 4, 7, 10. First term, common difference is 3. Then plus 3 like this. The general term UN equals U1 plus N minus 1D. So UN equals 1 plus N minus 1 times 3. So 3N minus 2. And then think about the K part. Is K, 2K, 4K, 8K. So first term is K. Then common ratio is times 2. So UN equals U1 times R to the power of N minus 1. So UN equals K times 2 to the power of N minus 1. Final answer, the number B, UN equals 3N minus 2 plus 2 to the power of N minus 1 times K. This is the May 2011 HL Paper 1 question. Number A. S infinity equals U1 over 1 minus R. We can rewrite as 81 over 2 equals 27 over 1 minus R. 9 times 9, 9 times 3. Then 3 times 1, 3 times 3. Then cross multiply. 3 minus 3R equals 2. Then minus 3R equals minus 1. R equals 1 over 3. Number B, V2 equals U2. U2 equals U1 times R. So 27 times 1 over 3, which is 9. V4 equals U4 equals U1 times R to the power of 3 equals 27 times 1 over 3 cubed, which is 1. And V2 plus 2D equals V4. V2 equals 9 plus 2D equals V4 equals 1. So D equals minus 4. V2 minus V1 equals D. V2 equals 9 minus V1 equals D is minus 4. Then V1 equals 13. Sigma n equals 1 to large N Vn equals V1 plus V2 plus V3 plus until V large N. Sn equals n over 2 times 2u1 plus n minus 1d. This means large N over 2 times 2 times v1 plus large N minus 1d. Large N over 2 times 2 times 13 plus large N minus 1 times d is minus 4. Then expand 26 minus 4n plus 4 n over 2 times 30 minus 4n, then 15n minus 2n squared. Then we can factor, take out n, then 15 minus 2n is greater than 0. Then use quadratic function. This is 0, this is 15 over 2 equals 7.5. It's not included, only between here. So n is greater than 0 and less than 7.5. Therefore n equals 7. This is the November 2011 SL Paper 2 question. Number A1. un equals u1 times r to the power of n minus 1. So u4 equals 40 times 1 over 2 to the power of 3, which is 5. Number 2. S infinity equals u1 over 1 minus r. So S infinity equals 40 over 1 minus 1 over 2. 40 over 1 over 2, which is 80. In an arithmetic sequence, u1 equals minus 36 and u8 equals minus 8. The general term, un equals u1 plus n minus 1d, then u8 equals u1 plus 7d. So minus 8 equals minus 36 plus 7d. Move minus 36 to the left is 28 equals 70. d equals 4. Sn equals n over 2 times 2u1 plus n minus 1d. So n over 2 times 2 times minus 36 plus n minus 1 times 4. Then n over 2 times minus 72 plus 4n minus 4. N over 2 times 4n minus 76. Then final answer is 2n squared minus 38n. Then u4 equals 5, S infinity equals 80. The common difference equals 4. Sn equals 2n squared minus 38n. Number C, the sum of the infinite geometry sequence is 80, is equal to twice the sum of the arithmetic sequence, which is 2n squared minus 38n. Then divide by 2 on each side. So 40 equals 2n squared minus 38n. Then divide by 2 on each side again. 20 equals n squared minus 19n. n squared minus 19n minus 20 equals 0. Then we can factor n minus 20, n plus 1 equals 0. So n equals 20 or minus 1. But minus 1 is not the answer because n is greater than 0. So final answer is n equals 20. This is the November 2013 SL Paper 1 question. Number A1. R equals 6 over n minus 1 or m plus 4 over 6. Number 2, the common ratio between two terms are the same. Then cross multiply m minus 1 times m plus 4 equals 36. Then m squared plus 4m minus m minus 4 equals 36. Then m squared plus 3m minus 40 equals 0. Number B1, we can factor m plus 8 times m minus 5 equals 0. So m equals minus 8 and 5. Number 2, if m equals minus 8, use this one. R equals 6 over m minus 1. So R equals 6 over minus 8 minus 1, 6 over minus 9, which is minus 2 over 3. If m equals 5, R equals 6 over 5 minus 1, 6 over 4, which is 3 over 2. We just found this. R equals 6 over m minus 1 or m plus 4 over 6, and m equals minus 8 over 5. When m equals minus 8, R equals minus 2 over 3. When m equals 5, then R equals 3 over 2. Then number C, 1. When R equals minus 2 over 3, the sequence has a finite sum when R equals between minus 1 and 1. So minus 2 over 3 equals between minus 1 and 1 is okay, but not 3 over 2. Number C2, U1 equals m minus 1, m equals minus 8, minus 1, which is minus 9. Then S infinity equals U1 over 1 minus R, minus 9 over 1 minus R equals minus 2 over 3, minus 9 over, make positive 5 over 3, minus 9 times 3 over 5. The final answer is minus 27 over 5. This is the last one. It is the November 2010 HL Paper 1 question. Number A, Sn equals U1 plus U2 plus U3 plus until UN, but before UN there is UN minus 1. So this sum is Sn minus 1. Therefore UN equals Sn minus Sn minus 1. So 7 to the power of n minus 8 to the power of n over 7 to the power of n minus 7 to the power of n minus 1 minus 8 to the power of n minus 1 over 7 to the power of n minus 1. Number B, S1 equals 7 minus a over 7. So U1 equals 7 minus a over 7. Then S2 equals 7 squared minus a squared over 7 squared. Then U2 equals S2 minus S1. S2 equals 7 squared minus a squared over 7 squared. Then we can factor 7 minus a times 7 plus a over 7 times 7. Then minus S1 equals 7 minus a over 7. The common factor is this part. Take out the common factor 7 minus a over 7. Then 7 plus a over 7 minus 1 equals 7 minus a over 7. Open the bracket. We can separate 1 plus a over 7 minus 1. Then 7 minus a over 7 times a over 7. In here, this part is u1, so u1 times a over 7. That means u2 equals u1 times r. Therefore, r equals a over 7. We just found the first term, u1 equals 7 minus a over 7. Then d equals a over 7. Number C1. The common ratio r must be between minus 1 and 1. So r equals a over 7 is between minus 1 and 1. And times 7 on both sides, minus 7, a 7. And a must be greater than 0. The final answer is a is greater than 0, less than 7. Number 2, as infinity equals u1 over 1 minus r equals 7 minus a over 7 over 1 minus a over 7 times 7 over 7, then expand 7 minus a over, the first one is 7, minus second one is a. The final answer is 1. I hope this video has been helpful. If you have any questions, leave them in a comment below, and I will address them in a future video. Thank you for watching. Please like and subscribe for more.